A hexagonal lamina of size 25 mm, definitely we required a side length that is 25 mm is given. It is resting on one of its sides. It is the second condition we require. Whether it is resting on a corner or side, it is very essential. He says that a hexagonal lamina of size 25 mm rests on one of its sides. That's clear. On HP, that's what we require. So we require a plane should rest on HP, either on corner condition or on side condition. So here clearly mentioned that it's resting on HP on side condition. That is done. Then we require the inclination of the plane with respect to HP as well as VP. As given, the lamina makes an angle of 45 degree to HP on the side on which it rests. It makes an angle of 30 degree to VP, draw its projections. So as we discussed, we require three conditions. One condition where is resting, on HP is resting, correct. On which condition, either on the corner condition or edge condition. It says side or edge condition, that is done. Later, for the second position, we require the inclination of a plane with respect to HP is also given 45 degree. And third data we required is inclination of the particular plane with respect to VP. So all three data is given, so we can easily solve the problem. About this construction, I already explained in the previous class. So this is the first position of your problem. This is the second position of your problem. And this is the third position of the problem. In the first position, what we do is we're going to construct your hexagon. So how do you construct the hexagon? There are many principles are available. So I suggest you to go through the video links in the YouTube. You find your own way, like how do you construct the hexagon. So today I just forwarded one link, like how to construct the hexagon. That is just inscribe that hexagon inside the circle. So what we do in that video, what he explained, first you have to draw a circle of radius is equal to given length of the side. What is that? 25 mm. So I'll draw a circle of radius that is equal to 25 mm. Later, he's going to draw one horizontal line here, like this, he'll draw AB. Then, by taking this much of length, that is 25 mm length, he draw a circle and he'll draw the radius from origin to here. Then, keeping your divider here at this point, he's going to divide the circle into 6 parts. By the time I'll get the 6 sides of your hexagon. Suppose if I want to get this condition, that is edge condition, so instead of drawing horizontal line AB here, you draw vertical line AB here. That's the only difference. So if I draw vertical line from O to A like this, and if I start dividing from this point, like say for example, here to here is 1 point, here to here is second point, 25 mm length, again here to here, third point, here to here, fourth point, in here to here, fifth point, then here to sixth point. By the time I get the edge condition. So the only difference between the edge and corner is I'll draw here for the corner condition. Then I start dividing from here so that I'll get the corner here. If I draw vertical line from O to here, O to say for example B, and if I start dividing from here, I'll get the edge condition. You try this, the same diagram on the same video, what is explained, same thing. Only thing is to get your corner, I have to draw one horizontal line so that I'll get the corner here. To get your edge, I have to draw vertical line here. That's all. Okay. Later, if you have any doubt, you can ask me. I'll explain. Okay. So now getting into the problem, it says a hexagonal lamina, hexagon nothing but 6 sides. That is known to you everyone. So there are 6 sides: 1, 2, 3, 4, 5, 6. So that's why it's called hexagonal lamina. Upside 25 mm. Each side of length is 25 mm. This is 25 mm. This is 25 mm. 25, 25. Each side will be equal length of 25 mm. Resting on one of its sides on HP. That's why you can see left hand side you should get always a side or edge because it says resting on HP. Please remember the condition is similar to like I'll take a plane of hexagon and I'll keeping on your floor where you are sitting timing. So on the floor I'm keeping. When I see from the top end, say if I stand and if I observe this one, this plane, this entire area is visible to me. Correct? No? When I see from the top, say for example, assume that I keep this lamina on the surface, on the floor, and I stand up and I'll see from the top side, top view. What I'll see entire area of this lamina. That's why I'll mark this entire area as A, B, C, D, E, F by 6 corners. And I'll make it entirely dark area because I can see completely all the corners of the hexagon in the top view. That is the first position of your first step. Later, once I do this one, I start marking the notations. As I said, you can do it in your own way. Say, for example, A, B, C, D, E, F. That's one way. Otherwise, you can start randomly from anywhere. That is not a method. You can start from anywhere. So here in this problem, we started from here. A, B, C, D, E, F. Okay. Now, this is the first portion. Later, any side, any one length you have to mention, either here or here. Better you mentioned here only. The side of length is equal to 25 mm. That is dimension line. Make sure that this entire boundary should be dark enough because it is visible line because entire area is visible in the top side, in the top view. Now So before doing this, as you already know, you have to draw an XY line, thin line, mark this above is VP, below is HP, and here is front view, here is top view. This is quite common for all the problem. I don't repeat again and again. You please follow. You draw an XY line, a thick line, maybe a smaller thin line. Okay, you mark above is VP and below is HP. Then you mark this line as XY. That's what. Okay. Now I have to produce the front view of this object. How do I produce? When an observer stands here, when observer stands here and you observe from here, this end, don't confuse the top view and the front view. As I said, this lamina is kept on the a plane. Say, for example, on the floor where you are sitting. Okay. When I stand up and see, I can see entire cross section of this one. At the same time, suppose assume that this plane is kept on a table and I stand and I see from the exactly plane of your table. What happens now? Only these three edges can be visible. In the front view, only these three edges can be visible. Remaining three edges cannot be seen. Otherwise, one more shortcut method. The in the entire cross section, the edges which are nearer to the XY line will be always hidden points. So in this, there are six edges. What is that? A, B, C, D, E, F. Out of this, if I draw one reference line here, there are three points above the reference line. There are 3 points below the reference line. So these are the points nearer to the observer. That means that you can easily observe the points. That's why they mentioned A dash, B dash, C dash outside the bracket because these edges can be seen easily by the observer. Whereas these edges are nearer to the XY line. That's why they're kept inside the bracket. That's one of the shortcut method I can say. So F is nearer to XY line. That's why I kept inside the bracket. E is nearer to XY line. That's why I kept inside the bracket. Even D is also nearer to XY line. That's why I kept inside the bracket. That is one shortcut method. Or in analysis purpose, observer is observing from this end. Only nearer to him can be observed. A, B, C can be observed by him, whereas the remaining thing like D, E, F cannot be observed by him. That's why they are kept inside the bracket. That is the first position of your problem. Okay, so I explained how to construct this hexagon and I explained how to mark the notations A, B, C, D, and I explained how to get this front view. And again, to get this front view, I have to extend a line, exactly vertical line, projection line from A and F. Please remember, when line joining between the point A and F should definitely pass through a single line. Suppose if it's not passing, suppose deviating means your construction is somewhere wrong, that you have to correct yourself so that you make sure that, so it is one of the, what you can say, uh, technique to identify that the construction is correct or not. When I draw a vertical line, that vertical line should exactly passes through point A and F. Similarly, if I draw a vertical line through B and E, it should pass us through exactly through B and E. When I draw a line through C and D, it should exactly pass us through C and D. Okay. Suppose if by deviating by some distance, definitely it will be wrong. So you just make sure yourself, when I draw this line, it should be exactly perpendicular to this one. When I draw this reference line in the beginning, when I'm constructing, should be exactly parallel to this line. That you have to make sure. Suppose if I don't take exactly parallel line here before dividing the circle, definitely some deviation will be there. Definitely this will be deflected. So I don't see that line BE will be passing through the same line. That is wrong. So this part is, I hope it is clear to you. Now we'll move to second position. What is second position says? It is the inclination of the plane, the same plane with respect to HP. Here is given. The lamina makes 45 degree to HP. It's very simple. Take the same edge, same line of length. Okay, first you draw one line of small thickness or very low thickness, making an angle of 45 degree. Extend the line thickness is equal to from here to here. First you draw one line of suitable length of maybe a larger length at an angle of 45 degree thin line. Later I'll take a divider and I'll measure the length from here to here. Say for example A to B, I'll cut it here. And again from B to C. Again, I'll take B to C as a reference. I'll make this much of length is dark. So please remember, this is exactly similar to this much of length as well as same notations. So what I have to do, I'll copy the same notation wherever it is kept. Because what I'm doing is, I'm going to hold this point and I lift this point by an angle of 45 degree. That's the meaning. Okay, that means you have to copy same as it is over here. Correct? No, in the when you're solving in software, definitely we do that. We'll take this one, we'll move directly over here, and we'll rotate by an angle of 45 degree. When you go through the video, you'll come to know like how you do it. But here you cannot move. No, physically we cannot move. Whereas in the software you can move it. That's why what I'm trying to say is, you extend a line, you leave some suitable length here, maybe a 2 centimeter, whatever it is. You just see the space available in your sketchbook. Leave some space. It may not be 2 centimeter exactly, 2 or 2.2, whatever it is. Now mark this point. First draw an angle of 45, measure an angle of 45 degree. First draw one thin line of suitable length, maybe a larger length. Then measure from here to here. Say for example, some 6 centimeter or 5.5, whatever it is. Take this as a reference, cut this line. make this much as dark line, this much as dark enough line because it can be seen in the front view. Later, you mark this point A dash F dash inside the bracket and again measure from here to here, here to here. What is that length? Say for example, 3. So mark from here as 3 and mark this as B dash inside the bracket is E dash. Again from here, from point here, here to here, you measure it. You will get another 3 centimeters or so. Again, you take this as a reference and mark this one. So mark it as C dash and D dash. That is the front view of the second position. Now what I have to do? I have to get the top view of the second position. How do I do it? It is very simple. Extend the projection lines from the respective front view points and top view points. So what is that I'll do? Say I'll take from the point A. I'll take from the point A. From point A, I'll draw horizontal projection line. I'll draw horizontal projection line. How do I do it? Say for example, I'll take this point first because we start with the point A. So I'll draw projection, thin projection. Maybe it's not visible to you, but please remember you can draw a very thin line exactly horizontal. Remember, when I draw horizontal line, it should be exactly horizontal to xy line. Please keep in mind. If you draw somewhere, maybe somewhere here or just randomly you draw, definitely you don't get this exact shape. So this will be carried forward. Definitely at the end, this entire shape will be varied. So you're definitely going to lose a marks. So whenever I draw projection line, horizontal projection line, that should be parallel to xy line. Whenever I draw a perpendicular projection line, that should be always perpendicular to xy line. That you should keep in mind. Okay. Now, so we're about to get this the shape. How do I get it? Let's see. Now, extend horizontal projection line from this point A. So I just extended projection line, which is parallel to xy, and simultaneously I look at from the top end also. Again, I'll extend from here because A is located here. So I'll extend vertical projection line from here. So both the lines are meeting here. So this one is here and this one is here. So the intersection point I'll mark it as point A. That point A is done. Now I'll go to point B. Horizontally, I'll extend the point B from here and I'll see simultaneously where is the point B in the front view. Point B is here, correct? No, B is here, E is, both are here only. So from this one, I'll extend a vertical downward line so that both will meet at point B and this intersection point I'll mark it as point B. Then similarly, I'll extend from point C. See, I'm extending a projection line from point C horizontally and again I'll observe where is the point C. Where is point C is here, right? No, so I'll extend a line from here. So the intersection of these lines, vertical projection line and horizontal projection lines of the respective point will be meeting at one corner point. So that I'll mark it as C. Similarly, I'll extend a D here. Again, observe D. So I'll mark it here only. And D will be here. Again, from here, I'll extend the horizontal line and a E is here, somewhere here. I'll extend and I'll find the intersection of these two will be somewhere here. I'll mark it as E. Then I extend F. See, F is here. F I'll extend from here and F is here only. So I'll extend here. So I'll mark it as F. Please remember, when I extend a line from AF, it will be a same common line. When I extend a line from A and C, it should be same common line, horizontal line. When I extend a line from F and D, it should be same common line. Please remember, otherwise, suppose if you're not getting or your line is deviating means you are doing some mistake that you have to rectify. Please remember, when I extend a line F and D, that should exactly pass through F and D only. When I extend a line from A, projection line from A, that should exactly pass us through point C. Here also should get a same line. So that is second position. In the top view, we always mark it as the notation as A, B, C, D, E, F. Correct. Now, in the previous problem, I said it is A1, B1. So, okay, fine, you can take it also, but please follow the one notation. In the top view, you mark it as A, B, C, D. In the front view, you mark it as dash. That's all. Okay, no 1, 2, 3 required. From now onwards, you follow one notation. The top view, A, B, C, D, A, B, C, D here also A, B, C, D. But in the front view, it will be dash. The edge which can be seen by the observer will be inside the bracket. The edge which cannot be seen by the observer or the edges which are nearer to or the corner which are nearer to x line will be keep inside the bracket. Okay. Now second position is done. I hope it is clear to you. Now we'll move on to the third position. What is that? We require inclination of the same plane with respect to VP as it is given 30 degree to VP. The third position is inclination of VP. Please remember, first position is resting on which plane? HP plane. Second position is inclination of the plane with respect to HP. And third position is inclination of the same plane with respect to VP. So VP is given. Now, it's very important one. What it says, see, the lamina makes 45 degree to HP, that is done. And the side on which it rests, where it is resting? Resting edge is AF. Correct? No, this edge is given now. So the side on which resting, that particular edge makes an angle of 30 degree to VP. So that's very important one. In the previous problem, he spoke about the diagonals, but now he's giving the resting edge. So please remember, he has given the initial condition, particular lamina a rectangle, I mean, what is that? Hexagonal lamina resting on the side or edge AF. The same AF will be making an angle of 30 degree to VP. So we have to make sure that the AF will come into picture now. How do I do it? Can you see one line is drawn here 30 degree? I just said you can draw in this way or you can draw in this way also. In this particular problem, somewhere here he has drawn the line. See, can you see a thin line is drawn, a thin line making an angle of 30 degree to VP as drawn. Okay, this will be produced later. Please don't confuse. We have done with this step. Now we are here. Okay, we are about to produce this particular position now. So first draw one line, thin line this way. Maybe you can start from here also, or just identify the space available in your sketchbook. Please remember, you cannot split the positions. All the positions should be there in one sheet of paper. Say you draw one, maybe one or two positions here, and the third one will be drawn the next one. No, you can't do it. Okay, all the positions should be in one page. So that's why you can tilt your sketchbook and you can draw. You can make sure that you know how you're going to produce, so you can do accordingly. In the exam also, in a hurry, don't do it immediately. You just plan your area. So how many positions you're going to get, like how we exactly. Just imagine. Then you can go with the sketch, because once you draw this two position, later you come to know that you cannot produce this in the next immediately. Then what you have to do, you have to erase it. Then time will be lapsed, no, so that cannot be gained again. So what you do, the beginning only you decide like how you're going to do it, whether in the just a minute, some charts, please don't chat, you just listen. Hello, Ritesh, Manoj Kumar, Divya. Okay, I can see your charts also, right? Later we can do it. So don't chart. Yeah. So now just draw one line, an angle of 30 degree. Either you can draw in this position or in this position also you can do it. Okay. So both are same. So what is the condition you have to maintain? So when I draw a 30-degree line, this edge AF, that is this edge AF should be lie on that particular line. Suppose if it says a diagonal, say for example, it says diagonal AD or AB is make an angle. By the time this line which is passing through the AB will make an angle of 30 degree. But here the 30 degree will be with respect to AF, because it says the condition. What is the condition? The the side on which the lamina rests is makes an angle of 30 degree. His resting condition is AF, edge is AF. That's why we have to make sure that this AF will make an angle of 30 degree, not the corner, not the diagonal. So that's why I drawn a line, and this over this line, I'll make sure that this AF will be produced. Now, how do I do it? It's very simple one. See, first, you try to construct this rectangle. See, from here to here, I'll construct the rectangle. And again, I'll construct this rectangle. Okay. Because otherwise, we cannot produce this shape easily. That's why you please make sure that you're going to construct this rectangular. Say, for example, here to here is the rectangular width, and here to here is rectangular length, and here to here. So, all the four corners you make sure. So, this same shape we're going to produce in this way. We're going to produce the same rectangle in this way. How do I do it? So, for example, first measure this distance from here. See, you can see from here to here, not from F to A. The total length of the rectangle from here. See, from point, the intersection of these two lines. From here to here, you measure the length. So the same length you measure here and mark the points. Later, say this line you have to measure. Once you draw this line, say for example, is the reference line here, and this reference line will come over here. Say somewhere here it will come. Okay, from first reference point, say for example, first reference point is this one. We draw one more vertical line, exactly perpendicular line of this much. So from this line, for say for example, the first reference point is here. I'll extend the vertical line somewhere here. Similarly, we have one more vertical line here. We're going to extend like this. So I'll measure here to here, and I'll extend from this point. Say reference point is here. I'll extend this much here. Okay. Then I'm going to join these two lines. Then I'm going to join these two lines so that I'll get the rectangle. So it's in the same way. So when I know this distance, say for example, you can measure directly, correct? No? So take your divider, measure this length here to here. So from point here to here, you measure it, so you'll get F point. Again, from F to E, you measure it. So mark this F to E. So you'll get F and A now, correct? No? So F and A, make it dark. Remain this corner is as it is. This length is left as it is. So I required this length, I drawn already, and I required this much of length. So I marked that much of length from here to here. And again, F to E is already known to me. It's like, you have this position here. The same thing you're going to reproduce. Like, how do you reproduce? You just observe carefully. You have to first draw the rectangular box. You just imagine there's a rectangular box inside which we're going to construct the hexagon. Okay, so you take your help of your scale and divider, reproduce as it is. If the lines are perpendicular, you just extend the perpendicular line. If the lines are parallel, just extend the parallel line. That's all. By using this principle, you're going to construct this third position of your top view. How do I do it? As I said, you first try to construct this rectangle here, making sure that this FA will lies on the 30-degree line. Okay. Later, say for example, here only I'll explain. If I want to get this one, I know this length and I know this length, correct? No? So I'll take a reference point here. I'll measure this much of length here, and I'll again measure this much of length. I'll mark it down. So by the time I'll get the E. Okay. And I already drawn this one. Correct? No, I already done this one. Again, from here to here, I can measure. Again, here to here, I can measure. Once I get this one, I'll get the corner point here. Then again, here to here, I can measure. So I'll cut this one. So I'll get the D point. Again, D to C, I know the value. D to C, I'll measure. Say D to C, I'll same thing. I'll take it here. I'll get this point. Again, if I know this is the corner, this is the corner. This is the corner. What is the corner? This is the corner end. So I can measure this length randomly in your divider. So C to D, I'll just make sure that this corner I'm going to get. Again, from corner to B, I have the length. So I'll take this reference and cut it down. So I'll get the B point. Please remember one thing. So maybe you'll get some doubts here. It's very simple. You have to reproduce this entire part. What is that? Hexagonal, which is inscribed in a square as it is, making sure that this particular edge will be coming on the 30-degree line. Later, we just reproduce these lines as it is. Perpendicular line, draw one perpendicular line of this much. One more perpendicular line of this much. Again, one more perpendicular line of this much. Again, one more perpendicular this much. Say, for example, here to here, exactly F will be along the same line. I'll take this much of length and I'll cut it down. Again, from A, I'll take this much of length, I'll cut it down. Again, when I come here, I know this much of length, so I'll cut down here. Again, from here, I know this much of length, I cut down here. So there are many ways to produce this one. So you please go through it. Okay. Please go through it and reproduce it. So we have left with only 10 minutes. I'll quickly finish up this one. So once I produce this one, the same notation I'll keep carrying F1A as it is. B will be here, C will be here, D will be here, E will be here. Correct? No? Now, to get this third position front view, I have to extend the respective lines. I have to extend the respective lines from upward and horizontally. We'll start from A only. So here, please remember, A and D may not pass through the same point. Please remember, they are deflected now. Okay, you don't confuse with the previous one. Now, when I extend a line, it may not pass through D point because it is a third position. Definitely it varies. Okay. So now I'll extend a projection line from A and I'll just stop where it's going to meet with the horizontal projection line. Say, for example, horizontal projection is here. I'll extend it so that both will meet at the XY line. So I'll stop it there. I'll mark that A dash. Now I'll go to B. I'll extend vertical B projection line and I'll simultaneously observe where is the B point from the front view. So B point is somewhere here. I'll extend this line and I'll extend this line. So both are meeting at this point. So I'll mark it as B dash. Then I'll go to C dash. Directly I'll draw vertical line. Please remember always vertical line. It's not a spy line or irregular line. It's a vertical line perpendicular to XY. I'll extend a line from here and again C. I'm going to mark it here. So because C comes over here, so the intersection of C and C dash, I'm going to get it at this point. I'll mark it as C dash. Similarly, from D dash I'll extend here. Again, D dash is coming here. So I'll get the D dash point here. Again, from E, I'll get E here. Later, once I get all the corners, I'll keep join all the corners by straight lines, not by regular lines, straight lines, so that I'm going to get the, say for example, A to B. Because A is here, B is here. You cannot draw like this, correct? No? You just join continuously from A to B. So vertical line like this, A dash, B dash, B dash, C dash, C dash, D dash, D dash, E dash, and E dash, F dash. So this is your third position of your problem. So this is about the solving of the problem. Hexagonal lamina of side 25 mm rest on one of its sides on HP. The lamina makes 45-degree to HP and the side on which it rests makes 30-degree to VP. Draw its projections. So this is about your solution. So now if you have any doubt, you can unmute your audio and you can ask.